Greeting to our lecturer, Sir Jeffrey Abad, for DBM20023 Engineering Mathematics 2. My name is TRISYA from DKA Section 2. Now, I'm going to present my first presentation entitled Curve Sketching Using Differentiation. Curve sketching using differentiation. There are many tools for sketching function, which is MathCAD, scientific notebooks, and graphic calculators. It is important in this section to learn the basic shape of curves that you meet. An understanding of the nature of each function is important for your future learning. Most mathematical modeling starts with a sketch. You need to be able to sketch the curve showing important feathers. Avoid drawing X, Y boxes and just joining the dots. We will be using calculus to help find important points on the curve. The kinds of things we will be searching for in these sections are x-intercepts. We will use y equal to 0. In many cases, finding x-intercept is not so easy. If so, delete this step. Y-intercept, we will use x equal to 0. Local maxima use dy over dx equal to 0. Sign of first derivative change plus to minus. Local minima use dy over dx equal to 0. Sign of first derivative change minus to plus. Point of inflection use d square y over dx square equal to 0 and sign of d square y equal to and sign of d square y over dx square change. A local maxima occurs when y equal to 0 and y change find from positive to negative as we go left to right. Curve showing portion with positive slope in pink and negative slope in green. Local minimum. A local minimum occurs when y equal to 0 and y change sign from negative to positive. Curve showing positive slope in pink and negative slope in green. The second derivative. The second derivative can tell us the shape of a curve at any point. Positive second derivative, concave up. If d square y over dx square bigger than 0, the curve will have a minimum type shape which called concave up. Concave up curve where y bigger than 0 for all x. Example 1. The curve y equal to x square plus 3x minus 2 has dy over dx equal to 2x plus 3. Now, d square y over dx square equal to 0, and of course, this is bigger than 0 for all values of x. So it has a concave up shape for all x. Second derivative, concave down. If d square y over dx square smaller than 0, the curve will have a maximum type shape called concave down. Concave down curve where y smaller than 0 for all x. Example 2. The curve y equal to x power 3 minus 2x plus 5 has dy over dx equal to 3x square minus 2. The second derivative is d square y over dx square equal to 6x, and this is smaller than 0 for all values of x smaller than 0. So the curve has a concave down shape for all x smaller than 0, and it is concave up if x bigger than 0. Points of inflection. A point of inflection is a point where the shape of the curve changes from a maximum type shape d square y over dx square smaller than 0 to a minimum type shape d square y over dx square bigger than 0. Clearly, the point of inflection will occur when d square y over dx square equal to 0 and when there is a change in sign from plus to minus or minus to plus of d square y over dx square. Curve showing concave in green and concave down in pink. Example 3. Sketch the following curve by finding intercept, maxima and minima and point of inflection y equal to x power 3 minus 9x. The basic shape of a cubic when the coefficient x power 3 is. Keeping this in mind help with this sketching process. First, x-intercepts. Y equal to x power 3 minus 9x equal to x in bracket x square minus 9 equal to x in bracket x plus 3 in bracket x minus 3. Now y equal to 0 when x equal to 0, x equal to negative 3, and x equal to 3. Y-intercepts when x equal to 0 and y equal to 0. Maxima and minima dy over dx equal to 3x square minus 9 equal to 3 in bracket x square minus 3 equal to 3 in bracket x plus square root of 3 in bracket x minus square root of 3 equal to 0. When x equal to negative square root of 3 or x equal to square root of 3, so we have maximum and minimum at approximately in bracket negative 1.7, 10.4, and in bracket 1.7, negative 10.4. We could check which is which by trying some point near negative 1.7 and positive 1.7 to determine that the sign changes are. But we need to find the second derivative anyway for points of inflection, so we use that to determine max or min. Second derivative. D square y over dx square equal to 6x. If x equal to negative 1.7, yn smaller than 0, so max at negative 1.7, 10.4. If x positive 1.7, yn bigger than 0, so min at 1.7, negative 10.4. Point of inflection. D square y over dx square equal to 6x. Now, d square y over dx square equal to 0 when x equal to 0. And d square y over dx square change sign from negative, concave down, to positive, which is concave up, as x passes through 0. So, we are ready to sketch the curve. There is the graph of y equal to x power 3 minus 9x. The flowing points are indicated with dots. Local maximums negative 1.7 and 10.4. Point of inflection which is 0, 0. Local minimum which is 1.7 and negative 10.4. General shapes. If we learn the general shapes of this curve, sketching become much easier. Of course, the following are ideal shapes and there are many other possibilities. But at least this help get us started. Maximums and minimums are shown with a dot, while points of inflection have a plus symbol. Quadratic. Highest power of x, 2. Typical quadratic shape, which is parabola, curve is concave up with all up for all x. One minimums, no maximum. If it has a positive x squared terms, no points of inflection. For cubics, highest power of x is 3. Typical cubics shapes showing concave down to concave up. One minimums, one maximum, and 1 point of inflections. For quartics, highest power of x is 4. Typical quartics shapes showing local maxima and minima. 2 maximums, 1 maximum if it has a positive x power 4 terms. 2 points of inflection. For pentics, highest power of x is 5. Typical pentics shapes showing local maxima and minima. 2 maximums, 2 minimums. 3 points of inflection. Example 4. Sketch the curve and show intercepts, maxima and minima, and point of inflection. Y equal to x power 4 minus 6x squared. First, x-intercepts. Y equal to x power 4 minus 6x squared equal to x squared in bracket x squared minus 6 equal to x squared in bracket x plus square root of 6 and in bracket x minus square root of 6 equal to 0. When x equal to 0, x equal to negative square root of 6 and x equal to square root 6. Second, we should find y-intercept. When x equal to 0, then y equal to 0. 3. Maxima and minima. dy equal to dx equal to 4x power 3 minus 12x equal to 4x in bracket x square minus 3 equal to 4x in bracket x plus square root of 3 and x minus square root of 3 equal to 0. Now dy over dx equal to 0 when x equal to 0 or x equal to negative square root of 3 and x equal to square root 3. So we have max or min at 0, 0 and in bracket negative square root of 3, negative 9 and square root 3, negative 9. For second derivative, d square y over dx square equal to 12x square minus 12. Now y bigger than 0 for x equal to negative square root of 3, so in bracket negative square root of 3, negative 9 is a local mean. Now y smaller than 0 for x equal to 0, so in bracket 0, 0 is a local max. Now y bigger than 0 for x equal to square root 3, so in bracket square root of 3, negative 9 is a local mean. 5. Point of inflection. We now use the second derivative to find point of inflection. d square y over dx square equal to 12x square minus 12 equal to 12 in bracket x plus 1 in bracket x minus 1 equal to 0. When x equal to negative 1 or x equal to 1, if x smaller than negative 1, y bigger than 0, and for negative 1 smaller than x smaller than 1, we have y smaller than 0. The sign of y has changed, so in bracket negative 1, negative 5 is a point of inflection. If x bigger than 1, y bigger than 0, the sign of y has changed, so in bracket 1, negative 1, negative 5 is a point of inflection. So we are ready to sketch the curve. The following points are indicated with dots. X-intercepts in bracket negative square root of 6, 0 and in bracket square root of 6, 0, green dots. Local maximum, x-intercept and y-intercept in bracket 0, 0 in green dot. Point of inflection in bracket negative 1, negative 5 and in bracket 1, negative 5 plus signs. Local minima in bracket negative square root of 3, negative 9 and in bracket square root 3, negative 9 in magenta dots. Example 5. Sketch the curve and show intercept, maxima and minima and points of inflection. The question is y equal to x power 5 minus 5x power 4. First, x-intercepts. Y equal to x power 5 minus 5x power 4 equal to x power 4 in bracket x minus 5 equal to 0. When x equal to 0, x equal to 5. Y-intercept. When x equal to 0, y equal to 0. Maxima and minima. dy over dx equal to 5x power 4 minus 20x power 3 equal to 5x power 3 in bracket x minus 4 equal to 0. When x equal to 0 or x equal to 4, so we have max or min at 0, 0 and 4, negative 2, 5, 6. Second derivative, d square y over dx square equal to 20x power 3 minus 60x square. Now when x equal to 0, y equal to 0, which is neither positive nor negative, so we can conclude whether 0, 0 is a local maximum or a local minimum using the second derivative test. However, since the first derivative changed from negative to positive, as we take values on the left of 0 and then on the right of 0, we can conclude 0, 0 is a local max. Now, y bigger than 0 for x equal to 4, so 4, negative 256 is a local mean. 5. Point of inflections. We now use the second derivative to find points of inflection. d square y over dx square equal to 20x power 3 minus 60x square equal to 20x square in bracket x minus 3 equal to 0 when x equal to 0 or x equal to 3. If x smaller than 0, y smaller than 0, so we have a concave down shapes. If 0 smaller than x smaller than 3, y smaller than 0, which also give us a concave down shapes. There is no sign change, so at x equal to 0, there is no point of inflection. If x bigger than 3, y bigger than 0, so we have a concave up shapes. So the sign of y has changed, so 3, negative 162 is a point of inflection. Actually, as at x equal to 0, we have an interesting case where the second derivative is momentarily 0 but is positive either side of 0. It is a local maximum even though the second derivative is not positive, which is usually the case. So we are ready to sketch the curve. This is the graph of y equal to x power 5 minus 5x power 4. The following points are indicated with dots. X-intercepts 0, 0 and 5, 0 in green dots. Point of inflection 3, negative 162 in plus signs. Local maximum 0, 0 in green dots. And local minimum 4, negative 256 in magenta dots. That's all from me. Thank you for watching. Bye!